Hello and welcome back to our Coffee Shop Astrophysics Extraterrestrial Life Talk Part 3. Continuing on from where we left off before, we were talking about how to find exoplanets. And part of that discussion is we're looking at the changes in light. And so we can actually look at a spectrum, what we call a spectrum, that comes off of a planet as well. And so what is a spectrum? Well, if you take a prism to a bright light, it will break it apart, right, into a full, what we call a spectrum of color. So we range from infrared to ultraviolet. And so the same thing happens when you're reflecting light off of an atmosphere, or when light is actually traveling through the atmosphere. Something like that can happen as well. And we can use this information. We can look at a planet's spectrum to determine chemical properties of the atmosphere of that planet. So here's an example. So we have violet on the left and all the way down to infrared on the right. And what we're going to see is that it's actually going to be missing some information. So there are going to be gaps in the spectrum. And we know, I think actually Alex mentioned something about this earlier, the way light reflects off of different chemical elements. Because we know certain chemical elements to absorb certain colors, right? Certain frequencies of light. And so when something is missing from the spectrum, we can say, oh, well, at this frequency, we can be pretty sure that there's water in that atmosphere. So that's one way that we can determine what kinds of chemicals are present, and that further increases the chances of habitability for that exoplanet. Different methods of finding a planet's spectrum will include subtraction, which means that you can take the spectrum of the star and the planet in orbit together, and then you take just the star, and then you can subtract the spectrum of the star, and you're left with the planet. Another way is reflection. I mentioned reflection. So the light hits the planet, it reflects off of the planet, and you're left with a spectrum. Another way is transmission, or refraction. So the light travels through the atmosphere, it breaks apart, and you get a spectrum. One possibility is radiation from heat. If the planet is warm enough, you can actually get what we call a black body spectrum.
All right, thanks, Mark. So we talked a lot in this talk, and I talked in the first part about biosignatures. So these are signatures that come from organic processes. But we've also discussed sort of tangentially the concept of technosignatures. So as opposed to biosignatures, technosignatures are signals that provide evidence of some sort of alien technology. So this could include actual structures that we can see on a planet, waste heat from some energy processing technology, or even communication signals. So those communication signals may be directed toward us, or they may just be within the planetary system. So there's a possibility that we may be able to detect them, but we'll talk more about the difficulties that in just a few moments. So Sophia Sheik actually outlined 9 axes of merit for different kinds of searches for technosignatures. So these are basically metrics that we can use to determine whether or not searching for a specific kind of signal is likely to produce a useful result. So these include things like observing capability and cost, both of which are related to how well it is that we could actually make the detection while not spending lots and lots of resource to do so. Ancillary benefits include just basically other science that we might be able to get, even if we have a non-detection of a technosignature. Detectability is fairly obvious, whether or not the signal we expect to find is likely to be detected at whatever distances and in whatever part of the galaxy we're looking. Duration of the signal is obviously important because very short-lived signals are going to be much harder for us to detect. Ambiguity also plays an important role because while there are many signals in the universe that may seem to be from extraterrestrial life, we need to be able to definitively say that whatever signals that we detect are not actually produced by some other physical process in the universe. Finally, the last 3, extrapolation, inevitability, and information, have to do with how likely it is that we could actually receive this information, how likely it is to actually have been created by the organism, and whether or not it would contain information. So the last slider, the information slider, could be comparing a detection of waste heat signal, which really only would tell us that there is life or that there is something creating waste heat, compared to, say, a beamed communication signal where they may be telling us, hi, we're extraterrestrial life. We live at these galactic coordinates. Come find us. That obviously would contain a lot more information that we could use. So in the history of science, we've had lots of, false alarms of what we assumed might be technosignatures initially. So one big one that happened in the late 60s was the detection of the so-called mysterious repeating radio signal by Jocelyn Bell and her advisor, Anthony Hewish. So these were regularly spaced pulses in radio light that were detected from a specific location in our galaxy. And the regularity of these pulses struck Dr. Bell and Dr. Hewish as very odd. There are few things, or at least in their time period, there were very few things that were so regular and constant in time as this signal. So their first thoughts included that this could possibly be a signal sent from an alien civilization that was attempting to contact other life in the galaxy. With more studies, this signal actually was determined to be what is called a pulsar. So this is a type of dead star that rotates rapidly and beams radio light out of its magnetic poles, which of course is not actually a sign of life. Similarly, in the very popular movie Contact, made in 1997, written by Carl Sagan, yes, Jodie Foster, of course, heard a similar radio signal, repeating prime numbers, and interpreted them as well as alien life. And of course, in that movie, it was in fact alien life. So there are a lot of problems and difficulties with disentangling these technosignatures from alien life or alien technology from other natural phenomena. One big problem is that the galaxy, of course, is giant. And as Mark mentioned earlier in the talk, despite the fact that the speed of light feels basically instantaneous for here on Earth, when we're talking about galactic distances or even extragalactic distances, the speed of light still means that it takes a long time for light to get across the galaxy or into different places. So this image actually shows a representation of our so-called radio range, or the extent of our radio broadcasts. So you can barely see, but in the bottom right panel, there's a tiny blue dot at the center. And that tiny blue dot is actually a small circle that is the roughly 200 light years worth of distance from Earth, where all of our radio broadcasts since the beginning of our radio broadcasts have reached. So obviously this is a tiny, tiny, tiny portion of our galaxy, which means that even if there is an alien life that is relatively close to us on a galactic scale, it still may be hundreds or thousands or millions of years before any of their light reaches us, or vice versa. So this is a big problem for our detection of alien life, because the galaxy is just so huge and light takes a long time to traverse these huge distances. Similarly, while we, of course, have lots of technology that we can use to communicate with one another quite easily, alien life may use some different form of energy or technology to communicate, in which case their signals may be reaching us, but maybe we don't have the technology to actually interpret those signals as alien signals, in which case they're passing by undetected by us. So all these things, as well as many other issues, certainly make the concept of detecting technosignatures difficult on Earth. But in our next section, we'll discuss a little bit about the kinds of technosignatures that we are actually emitting for the rest of the galaxy. So make sure to stick around.